Now we will move towards schematic arrangement of gas turbine power plant. Okay, so see here the schematic arrangement of gas power plant is shown on the next slide. The main components of these power plants are, now see here, so these are the total 6 main components of this gas power station. Okay, so हे 7 जे आहेत that is nothing but the main components of gas turbine power plant. Okay, so anybody tell me the main components of nuclear power plants are how many? How many main components are there for nuclear power plant?
Six.
4.
Okay, very good. 4. Can you tell me which are the 4 components?
Alternator, nuclear
good.
reactor,
Very
heat
good.
exchanger and steam turbine.
Okay, heat exchanger and third one is, last one is
Steam turbine.
okay, very good. So these are the 4 alternators: steam turbine, heat exchanger and nuclear reactor. So see here, these are the most important components for nuclear power plant, while these 6 are the important components for gas turbine power stations. Okay, now we will see one by one these power plants. Okay, sorry, these components. First of all, we will see what are the 6 different components. Okay, first is compressor, second one is a regenerator, third one is a combustion chamber, fourth one is gas turbine, fifth one is an alternator, and sixth one is a starting motor. Okay, so these are the total 6 main components. So this is the schematic arrangement. Okay, so see here, compressor is the first component, second is a regenerator, third is a combustion chamber, fourth one is a gas turbine, fifth one is an alternator, and last one is an starting motor. So this is the schematic arrangement. Okay, now we will see the schematic arrangement of this gas power plant. Okay, now see here, we have seen that the first component is a compressor. So the compressor is used in the power plant is generally of a rotatory type. Okay, see here, these compressor are used are nothing but a rotatory type. Why these are rotatory type? Because see here, the shaft, okay, same shaft is there for gas turbine, same shaft is there for alternator, same shaft is there for starting motor. We know that. Okay, now see here, rotor of the alternator is coupled with this shaft. If the rotor start rotating, this shaft is also rotating. Okay, we know that motor having the rotor, and that rotor is also connected to this shaft. That means this rotor is also having rotatory type. Now turbine is start rotating, and this turbine is coupled with this shaft. That means turbine is also rotatory. Now this same shaft is connected to the compressor. So these compressor are of rotatory type. Okay. The air at atmospheric pressure is drawn by the compressor via filter. Okay. Now see here, in this figure, filter is there. Okay. Because if this compressor has to absorb the air from atmosphere, okay, now if compressor has absorbed some moisture, some gases will be there in this air, so we have to remove this moisture and air. So for that purpose some filters are used. Okay, now this compressor will absorb the air, okay, by atmospheric pressure with the help of a filters, and this filter removes dust from the air. Okay, the rotatory blade of compressor push the air between the stationary blade and rise its temperature. Now see here, this compressor, I have told you that rotatory part are there. So the rotatory blade of alternator push the air between the stationary blade, right? Now we here is a pushing of air is there, right? Now at normal the air is having low pressure, but due to the rotatory blade some pushing mechanism will be there. Due to the pushing the air are having higher pressure, or that means from no pressure to high pressure or no pressure of this air will increase or rise in the pressure will be happen due to the rotatory blade that pushes the air. Okay, now thus this air at high pressure is available at the output of compressor. That means now this normal or atmospheric air is having the high pressure, and this high pressure air will be available at the output of compressor. Okay, now see here, this compressor is there. This compressor absorb the air from atmosphere with the help of filter. This filter will remove moisture as well as dust from the air. Okay, now in this compressor, see a rotatory part is there. Now air is moved towards this position. If the rotor is there, rotating blades are there. Due to this rotating blade, this no pressure or atmospheric pressure air will raise its pressure to a high pressure. Okay, now this high pressure air will be available at the output of this compressor. That means here the high pressure will be available. Now from the compressor we will move towards regenerator. Okay, now we'll see what is regenerator. So regenerator is a device which recovers heat from the exhaust gases of the turbine. Okay, now see here regenerator is there. Okay, now regenerator is a device which recovers heat from the exhaust gases of the turbine. Okay, I have told you that when the gases are passes towards the turbine, due to this their heat, the steam turbine start rotating. Okay, now after the reaction of these gases with the turbine, these gases will be moved towards the exhaust system. Okay, I have told you that the efficiency of these power plants are less. Okay, why? Because the exhaust gases are having heat. Now we have to recover this heat. Now for recovering this heat we have to use a regenerator. So regenerator is device which recover heat from the exhaust gases of the turbine. Okay, so this exhaust is passed through the regenerator before wasting to the atmosphere. That means here whenever whenever the whenever the used gases are there, these used gases is moved towards the exhaust system, right? While passing through the exhaust system they have to move through a regenerator. Okay, now regenerator consists of a net of tubes containing in a shell. Okay, the compressed air from the compressor passes through the tubes on its way so that the combustion chamber. Okay, that means see here I have shown you the figure. First of all, we will see this last sentence. In this way, compressed air is heated by the hot flue gases. Okay. Now see here. Now air is there. Okay. Now this air will be moved. Okay. Now this high pressure air will be moved towards a regenerator. Okay. Now see here regenerator are there. In this regenerator some tubes are there. Okay, now in this tube high pressure steam will be moved. Okay, now see here, this high pressure air from the compressor will be moved or will be placed in a regenerator at the same time, right? Or before, first we will complete the first cycle. Okay, first we will complete the first cycle, after that we will see the second cycle. Okay, now high pressure air will be moved towards the regenerator. Okay, now this high pressure air will be moved in this way and finally move towards a combustion chamber. Okay, now I have told you that in this combustion chamber some fuels will be burned so that heat will be produced. Now due to this heat, this air will be having heated, so this heated air as well as high pressure air will be moved towards gas turbine. Now the high pressure as well as heat of this air will be utilized by this turbine. Now this turbine start rotating, so due to this rotation alternator start rotating, this alternator produces electrical energy. Okay, now this used gases or this used air, okay, now this used air will be moved towards this exhaust pipe. Okay, now this used air has to be moved from this exhaust pipe, but we know that this exhaust gases or exhaust or used air are having less amount of or having the less amount of heat. Okay, now this less amount of heat we have to use. Okay, now this exhaust gases will be moved towards a regenerator. Now this exhaust gases will be placed here. Okay, now we know that air will be moving towards this tubes with the help of compressor, right? And the exhaust gases will be here. Now the heat of these exhaust gases will be exchanged in the regenerator to the high pressure steam. Okay, in the second cycle, now in the second cycle this high pressure heat will be, now this high pressure air will be heated in less amount with the exhaust gases in the regenerator. Okay, now if suppose at this point this air is having high pressure and temperature is 0. Okay, that means heat of this air is 0 or the temperature of this air is 0. Now it is moving towards regenerator. Now this is moving towards regenerator, but already here are the exhaust gases due to, okay, due to this turbine. Okay, now this turbine is moving, this turbine is provided the exhaust gases to the regenerator, and this regenerator are having some heat. Now this heat is exchanged with this air. Now the temperature of this air will be increases from 0 to minimum value. Okay, that means it will be moved towards 0 to 20 or 30 degrees Celsius. Now the remaining temperature or high temperature should be provided by combustion chamber. Okay, now in this way we can use, the total heat of the exhaust gas. Okay, so in this way we can increase the efficiency of the power station. However, some less amount of heat will be there. Okay, so this exhaust gas having less amount of heat will be directly exhaust from this section. Okay, so this is the working of a power station. Now we will move towards third section, that is nothing but combustion chamber. Okay, now we will see in this combustion chamber how the temperature will be provided. So see here, in this combustion chamber the air at high pressure, now in this combustion chamber air at high pressure from the compressor is laid to the combustion chamber via regenerator. In the combustion chamber, heat is added. Okay, now in this combustion chamber, heat is added to the air by burning oil. Now see here how we can provide a heat to air by burning the oil, so that these type of power plants are called as a gas power plant or oil based power plants. Okay, because the burning fuel is oil. Okay, so instead of gas we can say that this is also an oil power plant. Okay, now see here, the burning oil will be there. Due to this burning oil, heat is produced, and this oil is injected through the burner into the chamber at high pressure, and to ensure atomization of oils, and it's through a mixing with air. Okay, that means see here the burning of oil will be takes place, and due to this burning heat will produce. Okay, that means see here the result in the chamber attains a very high temperature, and I have told you that this very high temperature is nothing but 3000 degree Fahrenheit. Okay, now the combustion gases are suitably cooled. Now the combustion gases are suitably cooled to 1300, that is 1300 degree Celsius Fahrenheit, sorry, degree Fahrenheit to 1500 Fahrenheit. Okay, and then it is delivered to the gas turbine. Okay, now see here in this combustion chamber, if this high pressure air will be heated. Okay, it will be heated with this temperature, and it will be finally moved towards a gas turbine. Now there is a gas turbine. So the gas turbine is nothing but the product of combustion consists of mixture of gases at high temperature as well as pressure. These are passes towards the gas turbine. These gases in a these gases is passing over the gas turbine blades and expand, and they perform the mechanical work, so that the temperature of the exhaust gases from the turbine is about 900 degrees Celsius. Now see here from the combustion chamber, now the combustion chamber, it will provide 15,000 degree Fahrenheit temperature to the air. Now this 1500 degree Fahrenheit air will be moved towards gas turbine. Now this high pressure and high temperature of this air will be utilized by this gas turbine to start rotation. Now this start now this gas turbine is started. Okay, now this gas turbine produces a mechanical rotation, and this gas turbine is coupled with an alternator, so electricity will be used. Okay, now the exhaust gases are there. Okay, now the exhaust gases are there over the gas turbine, and these exhaust gases are having how much amount of energy or how much amount of heat? 900 degree Fahrenheit. Now this 900 degree Fahrenheit has to utilized to raise the temperature of air, so that this exhaust gases has to move towards regenerator for the extracting this heat. Okay, last part is nothing but alternator. So the gas turbine is coupled to the alternator, so alternator converts mechanical energy to the mechanical energy of the turbine into electrical energy. So the output from the alternator is given to the bus bar through the transformer, circuit breaker and isolators. And last is nothing but a starting motor. Before starting the turbine, compressor has to be started. I have told you that at starting we require some starting mechanics. Okay, see here this figure. First we have to start at this compressor. This compressor is a rotating part. Okay, now we have to rotate this compressor at first. So for that purpose this starting motor is required. This starting motor start or rotate this shaft, so that this compressor start rotating. Okay, that this starting motor is used. So before starting the turbine, compressor has to be started. For this purpose, an electrical motor is mounted on the same shaft that of the turbine. The motor is energized by the batteries. Once the unit started, the part of the mechanical power of the turbine drives the compressor, and hence there is no need of motor now. That means only this type of motor is used at the starting period. Whenever there is starting of power plant, okay, whenever there is a starting of power plant, there is no need, there is no further need of this motor. Okay, so this is all about the schematic arrangement. Okay, so in next lecture we will see, so this is the schematic arrangement. So in the next lecture or next tutorial we will start thermal power plant or hydroelectric power plant. Okay, only two power plants are left, that is thermal power plant and hydroelectric power plant. And after that we have to see some numerical based upon thermal and hydroelectric. Okay, so these things are remaining in the unit number 1. So is there any problem or any query regarding gas power plant?
No, sir.
Okay,
No, sir.
No, sir.
okay.